Alright, like magic, we have gone forward in time, and we're still working here. Same idea. So we're still going to go through that same process. We're going to draw a picture to help describe the situation, and then try to get to the part where we're talking about this second layer ratio. So let's start with the inside layer here. Cosine inverse of x. Remember, that really means x over 1. So that gave us two pieces there. That's saying that the x is the adjacent and the 1 is the hypotenuse. Very similar to what we saw before, but over here we had 1 for the hypotenuse, that's the same, but x was the opposite. Okay, so now for the two sides I'm going to be given. It's right here. The adjacent side is x and the hypotenuse side is 1. There we go. So those are our two pieces. That means that I need to find this third side, most likely. Why? Because I'm using tangent, and tangent is going to be the opposite over the adjacent, which means I do need this opposite side. Well, again, Pythagorean theorem, we know that, let's call this opposite. We know that x squared plus opposite squared equals 1 squared. Doing some algebra here, we wind up getting opposite is equal to the square root of 1 squared, or 1 minus x squared. So that's this over here, square root of 1 minus x squared. That's just algebra, a lot like what we did before. So if this is our angle, our theta, you could say, then tangent of that theta is going to be equal to the opposite over the adjacent. The opposite in this case is 1 minus x squared in the square root, and the adjacent is x. So, slightly different there as well. We have over x instead of over 1. Alright, now we're getting slightly more complex, but really nothing different at all with these next ones coming here. So let's split our work so we don't overlap anything here. I'm going to continue with this part by doing the inside layer with a different color here, just so you guys can see. So the cosine, we have this is really 2x over 1. So cosine means that the 2x would be the adjacent, because adjacent over the hypotenuse. That means 1 is my hypotenuse. Okay, with that in mind, I know that I have the adjacent is 2x, the hypotenuse is 1, and then the third side is a mystery. And I need it because for sine is really opposite over hypotenuse. So I need to find this third side. So again, we're following the same pattern. We would see that 2x squared plus the opposite squared equals 1 squared. Doing some algebra, and one minor note here, 2x squared is really 2x times 2x, or 4x squared, plus the opposite squared equals 1, because 1 squared is 1. Simplifying all the way, we got opposite equals square root 1 minus 4x squared. So that's what this side is, over there. Here's our angle that we're talking about, theta. So sine of that angle is going to be the opposite, which is that big radical, 1 minus 4x squared, over the hypotenuse, which is 1. Excellent, 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 excellent. Okay, last one of these. Again, even though it's not there, it's really there, 3x over 1. So we got a ratio, and it's dealing with tangent, which means that these two pieces are the OA, the opposite over the adjacent. OA, OA, OA. So that means opposite is 3x, and adjacent is 1. So those are the two pieces I was given. Now let's look at the missing section here. That would mean, okay, this is almost easier than the other ones because it's 1 squared plus 3x squared equals the hypotenuse squared. Because that's what we're looking for, the hypotenuse here. So 1 squared, it's 1. 3x squared is 9x squared. We got the 1 equals the hypotenuse squared. So if I just want hypotenuse, that means I got to square root this other side. So this right here, the hypotenuse is the square root of 1 plus 9x squared. Now they're going to ask us for sine. Here, sine. So sine theta is going to be the opposite over the hypotenuse, which is 3x over square root 1 plus 9x squared. Check. Done. And you guys are probably wondering, okay, why do we even need to do this? What's the big deal? And the big deal is that if we understand that relationship, it would be very beneficial for trying to do some of these derivatives backwards, because we know all the pieces instead of just part of them. So let's take a look at that. Here's what we're looking at. If y equals sine inverse of x, this is the same thing back and forward. Sine of y equals x. So how do I, okay, sine of y over 1 equals x. Or sine, pardon me, not sine of y over 1. Sine of y equals x over 1. And that's where we get this x and this 1 from. And the y is like the angle. And then we can find that third side. Why do we even need to do that? Well, because that third side has to do with the derivative. And here's what's happening. You know, if we took the derivative of each side, this is what we get. Cosine y dy dx. Why? It's implicit differentiation there. The derivative of x is just 1. So it's really 1 over cosine y. And cosine y, according to this picture, is the adjacent over the hypotenuse, which is square root 1 minus x squared over 1. Pardon me. Now this over 1, they didn't really include that. They just put square root 1 minus x squared. So that's what we got. That's crazy. We just figured out the derivative of sine inverse of x. So if y equals sine inverse or arc sine or the inverse sine, however you want to say it, of x, dy dx equals this. Boom. Done. But it required some geometry with Pythagorean theorem and SOHCAHTOA. So let's do this. This is just crazy. Okay, y equals cosine inverse of x. Notice that this is always easier if we first translate it. So we're going to translate it. That means that if I were to take the cosine of each side, and that's really what I'm doing. If I take the cosine of this, take the cosine of this, cosine of arc cosine, or cosine of cosine inverse, those are inverse functions. They undo each other. But the other side, we have cosine of y. All right, cosine of y equals x. So this is my angle here, and this is my ratio, really, x over 1. And thinking of cosine, that's CAH. That means we got the adjacent over the hypotenuse. So this x is the adjacent, and this 1 is the hypotenuse. So let's put those pieces together. So here's my x and my 1, my adjacent, my hypotenuse. That means adjacent is x, hypotenuse is 1. And based on earlier work that we were doing, we know that this other side here is something we would have to figure out, this opposite. Okay, so opposite squared plus x squared equals 1 squared. Do the algebra, you get opposite equals square root 1 minus x squared. Okay, why do we need to do that? Well, we're going to use it here in a second. 1 minus x squared. Now, take the derivative. So we're going to do d dx of cosine y and d dx of x. We're going to take the derivative of both sides. The right side, no problem. That's just 1. Over on the left side, the derivative of cosine is negative sine of y, but it's going to be also times dy dx. Then I divide both sides by negative sine y. And what do we get? Well, sine of y was the opposite over the hypotenuse, and the opposite in this case is 1 minus x squared, all square rooted, and the hypotenuse is 1. So this is going to be 1 over negative 1 minus x squared inside a square root. That's my dy dx. Okay, that was crazy. So what was the process we went through there? First thing that we were looking at is translate between y and x. Get it into no cosine inverse, but just trig of y equals x. Then the second thing, we needed to look at the triangle and find the missing pieces. We had to complete the triangle. And third, we had to do dy dx and substitute back in. Alright, so I'm running out of space here. Let's do this next one. Same idea. Tangent inverse of x is y. So if I want to find dy dx, first I got to translate both sides. That means that we're going to have tangent of y equals x. And even more so, equals x over 1. Alright, okay. So that to me tells me I have a picture. Here's x, here's 1, and we're doing tangent, so that means this side is the opposite, and this side is the adjacent. Why? Because we're doing TOA. Soka TOA. So opposite is x, adjacent is 1, and then the hypotenuse we got to figure out. Well, let's do that in a different color. There we go. The hypotenuse, we don't know. That's a question mark. But I do know that 1 squared plus x squared is equal to the hypotenuse squared. Now even more simply, square root of 1 plus x squared, because 1 squared is 1, equals the hypotenuse. So now that we have that information, we can apply it to what we need. 1 plus x squared. So what is, we have tangent of y. Let's do this kind of in a third stage. And I'll do this part here in blue. So the third stage that we're looking at, if tangent y equals x, I could take the derivative of both sides. Well, tangent, the derivative is secant squared y, and then of course the dy dx. Equals, and then on the other side, the derivative of x is just 1. Okay, so I'm going to divide both sides by secant squared y. Secant squared y. This actually almost simplifies it even more, because 1 over secant squared, guess what that is? That's just cosine squared y, because 1 over secant translates to cosine in the same way that 1 over cosine translates to secant. So we need to find cosine squared. So that means that we need to find the adjacent over the hypotenuse, and we need to square it. So the adjacent in this case is 1, and the hypotenuse is this crazy radical, 1 plus x squared, square rooted. But since we're squaring both of those, it just becomes 1 on top, and then on bottom it's going to be 1 plus x squared. Done. Okay, alright, we're working our way through here. So there's some shortcuts, and here's what generally happens. And of course we got the chain rule happening, but the derivative of sine is this. Then we got cosine, which is really the same except it's negative. And then the last one here is tangent, where because we had that squared, we removed the radical for the denominator. So, some basic ideas there. Let's see if we can apply them. So I know that if this is the derivative, I'm going to use the shortcut now. That means that dy dx is going to equal 1 over square root of 1 minus x squared, or I shouldn't say x squared, this is really u, times du dx. Well, then what's u? U would in this case would be 4x, u squared would be 16x squared, and du dx would just be 4. So this would simplify to 1 over square root 1 minus 16x squared times 4. Easy breezy. Next, okay, so I'm looking at this and it's tangent inverse. And I know that the rule that goes along with that one, the shortcut would be dy dx equals 1 over 1 plus u squared times du dx. All right, so in this case, u is x cubed. U squared would be x to the 6th, and du dx is going to be 3x squared. So let's put these pieces together here. Y prime, or dy dx, is going to be equal to 1 over 1 plus x to the 6th times du dx, which is 3x squared. Looks like I cut some of this one off, but I'm pretty sure that's a 2. Let's make that assumption there. And we have a chain rule. Okay, so that's kind of crazy. We got an outside, an inside, and on the inside we actually have kind of a third layer as well. So let's break this down piece by piece. First, when we look at dy dx, the outside is just going to be 3 times that inside squared. The first time we leave it alone, so it's cosine inverse of x over 2. But if I'm looking at this cosine inverse, the derivative of that we saw before was dy dx equals negative 1 over square root 1 minus x squared times du dx. And in this case, u equals x over 2. So u squared is going to be x squared over 4, and du dx is going to be, what's the derivative of x over 2? 1/2. Okay, so in here I got to squeeze in all this. Let's fit it in there. Do like a dark gray. Okay, so it's negative 1 over square root 1 minus x squared over 4 times, what's du dx? 1/2. There you go. And could that be simplified? Yeah, but I'm not too worried about that right now. That should kind of work itself out. All right, almost the last one. In fact, it's going to be the last one for this video. The next one is actually going to be in its own separate video, and we're going to go over it in class as well. So here, I got a bunch of stuff going on, a bunch of stuff. So I see first product rule with A and B, and then let's call this C. Then I'm going to say that dy dx is going to be equal to AB prime plus BA prime plus C prime. So we're going to do this in kind of 3 stages here. So A equals x and B equals sine inverse of x. So AB prime is going to be x times the derivative of sine inverse of x, which is 1 over square root 1 minus x squared. Now for the second part, we have BA prime. So that's plus sine inverse of x times 1. So that's just sine inverse of x. Good. And then c prime. This is actually kind of a layer function here. So if you think of this as 1 minus x squared to the 1/2 power, and we're going to take the derivative of that, winds up becoming 1/2 times 1 minus x squared to the negative 1/2 times negative 2x. So this is going to be added on here plus this right there. And that's not going to fit in that space. So I'm going to leave it right there. So that's our derivative. Big, sloppy, complex. Alright, so this is the end of this video. The last question, number 15, will be in a separate video just because it's got so many parts to it. It's almost its own little beast on itself. Okay, so at least watch the first 2 parts of the video, and we'll be going over the third one in class, and it'll be up there for you to review as you need as well. That's it.